Hello, geometry. We got a way to take notes again. We're doing that flipped learning like we talked about way back in December, in which you get to watch the videos and learn more about the information outside of class, but then in class we could actually work on the homework. The last time we did it, I had you take notes within class and then work on the assignment. And that was, we did that on the truth tables is when we had done that. Now, what's going to happen is you're going to do the same thing, but I'm going to expect you to do more of it outside of class. So in class, we can just concentrate on the assignments and the work as far as doing different projects and some of those other things. So we don't have to worry about the content of the material. You're going to get that in the video. So let's get started here. Today, we have angle pairs and parallel lines. Well, we're not going to get to parallel lines today. We're just going to talk through all the different types of angle pairs. So here's what we got to begin with. We have this thing called a transversal. And a transversal is just a high way of saying any line that intersects two or more lines in a plane. So when we look at our figure here to the right, we see that angle, our line T, seems to intersect the other lines M and L on this plane. Actually, since M and L are not parallel and they would continue on forever, they'd actually cross each other too. So in essence, all three of them are transversal. But for our case, the transversal is the line that's crossing the other two. And when a line is a transversal, it creates 8 angles on the two lines that it intersects. And those 8 angles all land in these different kinds of angle pairs. Well, the first one is a review for us. It's adjacent angles. Adjacent angles are any two coplanar angles that share a vertex and a common side, or you call it a ray, but have no other points in common. So when you look at the figure, we notice that 1 and 4 happen to be adjacent angles. 5 and 6 are adjacent angles. And we can go through all the different combinations, any of them that are side by side. Remember, that was kind of our little way to remember it. They were side by side. Let's see if that'll. Of course it won't. There we go. Let's see if that'll. There you go. Side by side. It's kind of what we said for adjacent angles. They're side by side. Now, we gave us the idea that we have linear pairs, and there are any two adjacent angles whose non-common sides form a straight line. So the same as I have highlighted, 1 and 4 are a linear pair. They share the edge that's going up towards the T, and the other ones are making line M. 1 and 2 are a linear pair, 2 and 3 are a linear pair, 3 and 4 are a linear pair, as well as the 5 and 6, and the 6 and the 7, and the 7 and 8, and the 5 and 8. We know all that already. So those are good to go. Now, the next set are vertical angles. We've had these two, and they're any two angles that are the opposite corners in an intersection. So when I look at this, I'm looking at angles like 2 and 4 are vertical. They're opposite corners. 5 and 7 are vertical. They're opposite corners. With that, 6 and 8 are vertical, and 1 and 3. Vertical angles do not have to be straight up and down. They just have to be the opposite corners of an intersection. And we have that postulate or theorem that said that the opposite angles, or these vertical angles, are going to be congruent. So we know 1 and 3 have the same measure. We know 2 and 4 have the same measure. That was one of those things that we actually proved here just before Christmas break. Now, where do we go from there? We come up with this idea of what we call corresponding angles. Corresponding angles are any two or more angles that hold the same position but in different intersections or figures or locations. So to be corresponding, the big thing here is that they have to hold the same position. They got to be in the same place. So in this case here, 1 and 5 are corresponding angles. They're both, when I look at it, kind of the upper left intersection, or the top intersection, if you want to think of it that way. 7 and 3 are corresponding angles. They're both that bottom one, or the bottom right, if you want to think of it that way. Let's see, 4 and 8 would be corresponding. They're both kind of the one on the left, or if you want to think of it, bottom left. And then that would leave 2 and 6 as being corresponding angles. They hold the same locations in these intersections. And that's all it takes to be corresponding. They just have to hold the same locations. That comes up with the idea then of interior. When two lines intersect or are cut by a transversal, the region between these lines is called the interior. So all of this inside here, all this space in here, lots of space in there is the interior of these angles, of these two lines. That's our interior area. So when I look at it, I can have alternate interior angles. They're going to be the angles that are on the inside there, but are on opposite sides of the transversal, but do not make a linear pair. Now that's kind of key there, that they cannot make a linear pair. So when I look at it, 2 and 3 right here are both in the interior. It's in the shaded region, but they're side by side making a linear pair. So 2 and 3 are not alternate interior angles. Rather, see if I'll just undo that one. Rather, 3 and 5 are alternate interior angles. Because they're both inside, they're in the blue region, in the interior, and they're on opposite sides of the transversal. Likewise with that, 8 and 2 would also be alternate interior angles. They're alternate interior. They're on the opposite sides of it. Keep this eye figure in your head here as we go scrolling down through these. Our next one is the same side interior angles. So unlike our last one, where they were alternate interior, we went same side. So interior angles that are on the same side of the transversal. So instead of the ones that we had circled, I need the ones in that blue region that are on the same side of the transversal, which automatically tells us that they have to be from different intersections. So that means the 8 would be paired with the 3 as alternate interior angles, and the 2 here gets paired with the 5 as same side interior angles. So now down here, I've got angle 3 and angle 8 are on the same side and they're interior angles, as well as angle 2 and angle 5. So there's our angle setups there. So the ones that are between the two lines, either on the same side of the transversal, if they're same side, or what we might call consecutive interior angles, or if they're alternate interior angles and they're opposite sides of that transversal. Now this brings us to the idea of exterior angles. So thinking back up to that picture, we already identified the interior. So when two lines are cut by a transversal, the region not between the two lines is called the exterior. So when I look at this figure, I have the interior all highlighted. Well, that would mean everything that's out here would be considered exterior. So that yellow region is the exterior region. So any angles out there are considered exterior angles. So 1 and 4, 6 and 7 are all exterior angles. Now there's a special type of exterior angles, and these are called alternate exterior angles, and they're exterior angles that are on the opposite sides of a transversal, but are not a linear pair. So when I look at this, 6 and 7 are on opposite sides of the transversal, but they're a linear pair. So whenever I think about any of these angles down here at the bottom, the corresponding, the interior, alternate interior, same side interior, and this alternate exterior, I got to pick points from two different locations, two different intersections. So now, when I look at the 6 and 7, 8 is interior. It's not going to be one of those. 7 and 1, 4 and 5 work. 7 and 1 are alternate exteriors. They're in that yellow region outside of the two lines, and they're on the opposite sides of the transversal. So angle 1 and angle 7, I got to extend this a little bit. And then what did we say? Angle 4 and angle 6. So those are the different types of angle pairs that we have when we have two lines that are being cut by a transversal. So the transversal is the one that intersects the other two, and it creates those 8 angles that we're going to look at. From those 8 angles, there's a ton of these angle pairs that we have to look at. Your assignment that is due before class tomorrow is I want you to use this figure right here, go to the form in Google Classroom, bring it up, and it's going to ask you about different angles within this figure. Now notice the way it's lined out. T is a transversal for L and M. L is a transversal for T and M is a transversal for L and T. So when you look at it, there's a lot of different things to worry about. When I do that, what I do is if I have a problem in which I have to look for a couple different angles, what I do is I will hide what's not being used. So if my two angles happen to be, let's say, like 8 and 10, I would hide the angles at the intersections that didn't have the 8 and 10 in it, so then I can just concentrate down here. So now when I look at it, I can see that 7, 8, 9, and 10 are all between the two lines, so they're interior angles, and then I could go from there. If it said something about 1 and 3, I would get rid of that bottom set of points. I only want the two intersections that had the 1 and the 3 in. And then the last one would be is, if I had something along those other sides, I had a 3 and a, say, a 12, 3 and a 12. I'd want to use those two intersections. I completely hide the other one. So you need to get this object, this written down on your paper, and then do the form in your book. In class tomorrow, we'll have something more with this. Okay, get going, please.